Paper-to-code problem. Why is it so hard? Papers, especially in academia, might lack the detailed implementation specifics you need to actually build the system. You might struggle to fully grasp the complex math or theoretical concepts. Sometimes, even when code is provided alongside a paper, it can be messy, hard to read, spaghetti code, or not integrate well with modern software systems, meaning you might spend more time trying to understand or fix it than just starting over. There can also be misunderstandings about the specific domain or the software engineering process needed for implementation. Ultimately, a paper describing an idea isn't a direct, one-to-one blueprint for code. Historically, this meant a painstaking manual process. You'd need to dive deep into the paper, maybe write out the math step by step. You'd break down the algorithm into smaller, testable components. Building a working prototype is crucial to prove the algorithm functions on your data. Then comes the actual coding, selecting the right programming language and libraries, often dictated by existing systems. Good software engineering practices like documentation, choosing clear variable names, and using automated testing are essential but often lacking in research code. Literate programming, which intersperses code with natural language explanations, is one suggested approach to make research code more understandable and reproducible. But what if AI could help bridge this gap? This is where automated tools come in, falling under the umbrella of natural language processing for programming, NLP-4P, specifically tasks like program synthesis or program translation. Tools like Papercoder and YesChat.ai's Paper2code aim to automate this translation. These AI tools analyze the research paper, often focusing on implementation sections. They use AI models, sometimes powerful ones like GPT-4o, to understand the described methodology. The process can involve breaking down the complex task into distinct phases, much like human software development. This might include planning the overall architecture, analyzing specific components like classes and functions, and then generating the actual code. They can even generate necessary configuration files, like YAML files containing hyperparameters, by synthesizing information from the paper's plan and details. The goal is to generate code for various parts of a research methodology, such as data pre-processing, model architecture, using libraries like TensorFlow or PyTorch, training procedures, and evaluation metrics. The promise of this automation is significant. It can potentially accelerate the implementation of cutting-edge research, making advanced methods more accessible to a wider community and speeding up development cycles. By offloading routine coding tasks, it could free up human experts to focus on higher-level innovation. However, these tools aren't a magic bullet yet. Their success heavily relies on the clarity and detail provided within the original paper. Complex mathematical content or vision-specific details can still be difficult for the AI to interpret accurately. While impressive, the generated code often still requires human review and modification. One study mentioned that even with an automated tool, around 48% of the generated code needed some tweaks, typically minor ones like updating API calls or